Hi there, everyone. Thanks for joining today's session of the virtual classroom learning series with Green and Healthy Schools, Wisconsin. Happy to have you here for our presentation from LEAF. Before we get started, I want to take a moment to thank Skyward, who is sponsoring the classroom learning series.
Since our humble beginnings as a small family business, Skyward has evolved into a global technology leader serving more than 2,000 school districts. At Skyward, we are proud to support the initiatives of the Green and Healthy Schools Classroom Learning Series.
Today's presentation is titled Climate Change and the Trees Around Us and is being presented by Nicole Filizzetti of LEAF, the Wisconsin K-12 Forestry Education Program. Nicole works for LEAF in the Wisconsin Center for Environmental Education, where she helps teachers discover new ideas for bringing their students into the forest for learning. Before this, she was a science teacher in the UP, Michigan, and Florida. She currently lives in Minocqua with her husband and children, where she enjoys gardening, cooking, and watching deer in her backyard.
Folks, thanks for the introduction, Leslie, and thanks for joining me today as we learn a little bit about the role that trees play in climate change. Our format for the next half hour will be a little bit of me talking to you on screen, then we'll take a look at some visuals on a PowerPoint. We'll spend about 10 minutes watching a video of students learning some tree measurement skills that are used to collect carbon-related data. And then we'll do some thinking and apply the measurements to larger concepts by using some online tools. At the end of our time together, I'll share my email address and some useful web links where you can find some of the resources we discussed. If at any time during the next half hour you have any questions, be sure to write them down and you can email me for clarification. And I'm going to go ahead and share my screen now to the PowerPoint and we can get started. Before we get started, I'd like to take a minute to think about whose land I'm on as I do my work and live my life today. I encourage you to take a look at this map and do the same, and to spend a moment thinking about what this means to you. I acknowledge that where I live is a historic homeland of the Anishinaabe people and is currently the home of the Lac du Flambeau Band of Lake Superior, Chippewa. I'm grateful for the care that they and other Indigenous people have given to this land and these forests since time immemorial, and appreciate the ways their traditional knowledge affects my understanding of sustainable forest management and the work I do in education. Our Green and Healthy Schools webinar today, Climate Change and the Trees Around Us, is part of the Understanding Community Systems series being presented by different folks from the LEAF program. LEAF is part of the Wisconsin Center for Environmental Education in the College of Natural Resources at UW-Stevens Point. The first two parts of the series focused on tree identification and the role that trees play in flood control. And these recordings are available for you to watch anytime. We also have a fourth webinar coming up in December that looks at winter ecology, so I hope you can join us for that as well. If you've taken any chemistry or even physical science classes, you've probably learned that carbon is a massively important element in our world. You may even have heard the expression that carbon is the building block of life. Because of its structure, carbon can form complex and stable connections with many other types of elements, so it becomes the foundation of many important things in our world, including trees. If you were to cut down a tree, let it dry out, and then look at the wood, you could make the generalization that 50% of the dry mass of the tree is carbon. So where does that carbon come from? Ever since elementary school, if someone asked you, what do trees do? Chances are you would have answered that trees take in carbon and give off oxygen. And of course, this is true. And it's a simple summary of the process of photosynthesis. Trees also do the opposite, taking in oxygen and giving off carbon just like we do. But they do that at a much smaller rate when they go through cellular respiration. So let's take a closer look at what it means for trees to take in carbon. You've probably seen an equation like this before, which is showing the chemical steps that are happening in a tree's cells during photosynthesis. Carbon dioxide comes into the tree through its leaves, combines with water from the roots and energy from the sun, which is captured by the pigments in the tree's leaves like chlorophyll. This chemical reaction gives off two important things: glucose, or sugar, which the tree uses to grow, and oxygen. Lucky for us, the tree doesn't need most of its oxygen, so it gets rid of it through its leaves, where it enters the atmosphere and becomes available to other living things. If you look closely at the glucose in our equation, right here circled in yellow, you'll see that it also contains carbon. So the tree takes in carbon and makes oxygen, and then it uses some of the carbon to build more of itself. The tree stores some of the carbon that it takes in through the atmosphere as the tree itself. And as long as that tree continues to grow, or if it is cut and stays solid as wood, the carbon will continue to be stored there. If the tree rots or burns, the carbon will be released back into the atmosphere. Let's spend just a minute looking carefully at this graphic. I mentioned that some of the carbon that the tree takes in will be stored in the tree. You can see that happening in the parts of the picture that are circled in blue. Here, coming in for photosynthesis, and then it's stored in the stem and branches and foliage, which just means leaves, and it's also stored in the roots and in the litter of the soil. Another word for this process of storing carbon is carbon sequestration, and you'll hear me say that a few more times today. Looking at this picture, what are the ways that the carbon which isn't stored moves back into the atmosphere? So the parts of the graphic that aren't circled in blue. And we can see that the main ways this happens are through respiration from the tree or nearby soils and decomposition. So that's where we have our arrows going back out of the diagram. Carbon is being released back into the atmosphere. So we can see that a standing live tree or intact lumber from a cut tree are good ways to sequester or store carbon from the atmosphere. Climate change, which you might sometimes hear described as global warming, is occurring because the composition of gases in our atmosphere is changing. Greenhouse gases, including CO2 or carbon, but also nitrous oxide, methane, and fluorinated gases, are really good at holding in heat. Some greenhouse gases occur naturally and are emitted into the atmosphere through natural processes like volcanoes and also by human activities. In general, this is a good thing because they hold in heat that allows Earth to be a livable planet and not too freezing cold. However, the concentration of greenhouse gases has been rising since the Industrial Revolution about 160 years ago, increasing the atmosphere's ability to hold in heat. So it's almost like a blanket getting thicker. You can see this rising concentration shown here in this graph in the part circled in green. Many scientists are concerned about the effects of this rising CO2 and the associated rise in Earth's temperature. Some issues that are thought to be linked to a rise in greenhouse gases are coastal flooding, alteration of natural habitats, unstable weather patterns and increased severe weather, and an increased range of disease-causing organisms. So what do trees have to do with this? One way to combat the potential effects of climate change is to sequester more carbon from the atmosphere. As we saw from in our previous slide, trees are really good at doing this. There are a lot of charts and models out there to help us understand how much carbon individual trees can store and to learn more about the other important ecosystem services that trees play. Today, we're going to be using a tool from Project Learning Tree. If you look at this chart, you'll see that it uses a tree's height and diameter to estimate how much carbon can be stored by a single tree. You have diameter along the top and height along the side. You can use the trees on your school grounds or along the street at your house or in a local park to practice doing this. The measurements you need to take are quite simple, and the tools you need are simple too. I recently worked with 2 local students to make a demonstration video for you that shows how to find these measurements. Let's switch over to the video now.
When we're measuring a tree to calculate how much carbon it's storing, we're looking for 2 measurements, height and diameter. When measuring trees, diameter is referred to as diameter at breast height, or DBH. If we want to get more detail about the tree's usefulness, it's helpful to know the type of tree we're measuring, but it's definitely not necessary. Just knowing whether it's a deciduous tree or a coniferous tree is enough if you don't know what kind it is. Now, if you think back to math class, you'll remember that diameter is the distance across a circle, while circumference is the distance around the edge of a circle. Looking at this tree, you can see that wrapping a measuring tape around the tree is going to give us its circumference, not its diameter. Luckily, there are easy ways to calculate diameter from circumference. One of the easiest ways to measure diameter is to use a forester tool called a DBH tape, which is specially calibrated to automatically convert circumference into diameter. If you look at the numbers on the DBH side, you can see that they're not spaced out the same as they are for measuring inches. And that's because the conversion is already built in from circumference to diameter. DBH tapes are fairly low cost and they're easy to order online. So before you start measuring trees, you should ask your teacher if they happen to have any in their classroom supplies. If they don't, that's fine too, as we'll also be looking at ways of measuring with more common tools. There's also another tool for foresters to measure DBH called a Biltmore stick, but we won't be demonstrating that today. But if you're interested in learning how to use a Biltmore stick, send me an email and I will point you to some resources that help teach the process. You can even go to our website and print your own Biltmore stick to use if you want to. Whichever tools you're using, you're going to need to know how high up 4.5 feet is, because that's the height that DBH is measured. So step one with whatever measuring tool you're using is to find 4.5 feet up on the tree. If you're using a DBH tape for this, make sure you're using the regular side of the tape, not the calibrated DBH side. Once you have your 4.5 feet measurement, mentally mark it. And now you're just simply going to wrap the DBH tape around the tree, overlapping to 0 so you can see an accurate measurement. It's nice to have a second person helping with this, but it is possible to do it on your own if you use the end of the tape as a gripper. Once you found your DBH, be sure to write it down on your worksheet or jot it in your phone. So on this tree, what's our DBH?
15 7/10.
Show me where you're measuring that. Okay, and the DBH tape is sectioned off in tenths of inches. So 15 7/10, and we're going to write that down on our data sheet. If you don't have a DBH tape, you can use a flexible measuring tape that's used for sewing. And then we're going to do a simple conversion, since the measuring tape is not calibrated the way a DBH tape is. So we're going to still look at our same 4.5 feet marked up on the tree. And if you're not certain, then just measure it again. And there's no handy clip at the end of this tape, so it really is helpful to have two people. You'll notice that we're measuring DBH in inches, not in centimeters. And this is circumference, right? So what did we measure for our circumference?
49.5.
Okay, we've got 49.5. What are we going to do with 49.5 to turn it into a diameter measurement?
Divide it by pi.
Divide it by pi, divide it by 3.14. Okay, so let's get a calculator. We're going to write down 49.5. And we're going to divide it by 3.14.
15.76.
15.76. How does that compare to our first measurement?
Very similar.
Very similar? Okay, what could be some reasons, if the numbers were different, what could be some reasons why?
We used the wrong height.
Okay, so maybe you weren't exactly at 4.5 feet the second time, but those are pretty close measurements, so that shows us that the method using just a plain sewer's tape can work just fine too. A final method, if you don't have a sewing tape, is to just use a string and a ruler. You're also measuring circumference instead of diameter, so you're still going to need to do that 3.14 division, and you're also going to need to find 4.5 feet. So if you're using a ruler to do that, you need to be really careful. Now that we know the DBH of our tree, we need to estimate the height. There are many tools and methods that can help you with this, but today we are simply going to be using a ruler and a cool math trick. All you need is a ruler and a friend who knows their height. Do you know your height?
Yes, 5'2".
And what is that in inches?
62 inches.
62 inches. So we're going to write that on our data sheet and use that later in our calculation. Have your friend stand at the base of the tree. Try to be sure that they're standing on a level spot and not in a hole. Now you're going to move your position so that when you hold the ruler out in front of you, the bottom of the ruler matches the bottom of the tree and the top of the ruler matches the top of the tree. Depending on how big your tree is, you might need to move quite far away. One thing to note is that if we were foresters measuring trees to determine how many board feet of lumber they contain, we would not be measuring all the way to the top of the tree because we wouldn't want to include the branches. However, since our job today is to calculate carbon sequestration, and the branches are definitely important for that, we do want to include the branches. So make sure that you're lined up all the way to the top of the tree with your ruler. So from Primo's perspective, the bottom of the ruler is at the bottom of the tree and the top of the ruler is at the top of the tree. It doesn't look like that from where I'm standing because I'm about a foot back from him. So now looking at your tree, it appears that the tree is 12 inches high. We would say that the tree has an apparent height of 12 inches. Of course, we know that isn't the actual height, but we're going to be using a ratio of 3 other numbers to determine what the actual height is. If the tree has an apparent height of 12 inches, what is your friend's apparent height?
1 inch.
So from the perspective of the ruler, our friend looks like she's 1 inch tall. So be sure to write that down. Now that we know the apparent height of the tree, the apparent height of our friend, and the actual height of our friend, we have 3 numbers and we have almost everything we need to calculate the tree. What don't we know about the tree?
The actual height of the tree.
The actual height of the tree. Okay, so we're going to set up a simple ratio to find that unknown number. We need to divide the apparent height of the tree, which was 12 inches, by the apparent height of our friend, which was what?
1.
1 inch. And then we multiply this by the actual height of our friend in inches, which was what?
62.
62 inches. So what do we come up with for an estimated actual height of our tree?
744 inches.
And what is that in feet?
62 feet.
62 feet. So does that seem reasonable?
I'd say yeah.
That could be reasonable. It's a pretty tall tree, and if we were going all the way to the top branch, that could be a reasonable estimate. Do you have the DBH of your tree, the apparent height of the tree, the actual height of your friend, and the apparent height of your friend?
Yes.
Then we have everything we need to calculate this tree. We can also use some calculators on the web to learn about other ecosystem functions of our trees as well. Let's head back inside.
So thinking back to our trees in the video, we found that the large tree, which was a red maple, not a red oak, as it said in the data sheet, sorry about that. The red maple had a DBH of 15 7/10 of an inch, and it had a height of 62 feet. So let's plug those numbers into our chart from Project Learning Tree. We have DBH up along the top and height along the side, 16 inches here, 60 feet here, and then we follow those to the column in the row until they meet, and we find that that red maple stores 581 pounds of carbon a year. So this is in pounds of carbon. Now, if you're like me, that's kind of a random number because we don't really have anything to compare it to. So I did a little Googling and I found that the average car puts out 1 pound of CO2 per mile of driving. So using that, we could say that our tree stores 581 miles of CO2, if that's a number that makes more sense to you. So I would encourage you to take a minute. You can even pause my little presentation here. And do a little Googling of your own to find out some activities to compare our carbon measurement to. So Maybe you could compare it to an airline flight or meat production or some other anything we do that uses electricity releases carbon into the atmosphere unless you're using 100% renewable. So feel free to take some time right now and Google some of that if you want to before we move on. And if you do find something interesting that you want to share with me, you can send me an email about it. So now let's look at our second tree, which was much smaller. It was a blue spruce tree and it had a DBH of 6 9/10 and a height of 16.75 feet. So estimating at 6 and 15, follow our rows and columns down and we find that it stores 40 pounds of carbon in a year. So obviously much less than the bigger tree because it is a smaller tree. But that little tree there in that yard gets a lot of sunlight and it's growing quickly. So let's say that a few years go by and the tree gains 2 inches of diameter and 5 feet of growth. So 2 inches and 5 feet. How much carbon would it be able to store then? Take a look at the chart and see if you can find the number. So if it grew 2 inches, we move over to 8. Or excuse me, increase of 2 inches in its diameter, we move over to 8. A growth of 5 feet, we move down to 20. We meet here at 67. So hopefully you found that same number, 67 feet, or excuse me, 67 pounds of carbon stored in a couple years from that tree. So it really does increase quickly as a tree grows. So as we've seen, the ability of trees to store carbon is hugely important for our ability to slow the effects of climate change. But that isn't all that trees are useful for. I want to show you a cool website, which is powered by the iTree program that makes it easy to understand the economic and ecological importance of trees. So we're going to come out of the PowerPoint and we're going to go to www.treebenefits.com. Really easy to remember, treebenefits.com. So here we are at treebenefits.com, and this is the front page that it takes you to. You'll see it's called the National Tree Benefit Calculator. And the first thing it asks us to do is put in our zip code. I'm going to use my zip code because that is where those trees were measured. But I want you to think for a minute about why it matters where your zip code is. Why would the information change based on your location? If you give it a little thought, you might realize that trees grow at different rates depending on your climate, right? So I'm farther up north than some of you might be. Folks in the southern part of the country would have very different rates of growth than we would have up here in Wisconsin. So we put our zip code in, and here on the left, it's going to ask us to put in what we know about our tree. And if you remember from the video, I said that even if you don't remember or don't know what kind of tree you have, that's okay. So if you don't know, you're going to scroll down to the middle where it just has some other categories: broadleaf or deciduous, large, medium, and small. Conifer, large, medium, and small is what you would choose if you don't know what kind of tree you had. I do know what we had. We had a red maple in the first large one, and it was 16 inches. You'll see it's already popping up my answers because I have already put them in. And single family residential, that just means that it's a tree in a family's yard. Or if you have an apartment building, you would choose multifamily. And then these are if you're doing a tree that isn't at a house. So like at a business in town or a park. If you're doing it on your school grounds, you can just choose park or vacant land. And then I hit calculate and it comes up with some really interesting information about our tree. We're going to ignore this nice pie chart for just a second, and I want to jump over to CO2 because that's what we've already been talking about. And if you remember back a minute ago when we looked at our chart, we came up with a number more around the 550 range, right? So this website is also saying that the same or roughly the same as what we've had in our chart, but it's also adding a whole nother amount of CO2 that's being avoided. So what that means is this is the carbon that's being stored in the tree from the method that we talked about earlier, but this is the carbon that we are avoiding giving off because that tree is there. So how does that work? What does that mean? What that means is largely, I'm going to click on this energy tab. When we have trees around buildings, it it offers shade to those buildings, so it reduces the amount of heat of cooling we have to do in the summer, but it also blocks wind, so it reduces the amount of heating we have to do in the winter. So that's where some of that carbon is being saved. So we're not releasing as much because we're not having to heat or cool as much. That's a good part of why this number is higher. So it's just another interesting way of thinking about how the role that trees play in climate change. Not only are we actually storing carbon, but we're also reducing how much we emit through the activities that we do. And then we're going to jump back over to our pie chart here for just a minute, and it shows some other really neat ecological benefits that trees have, or that trees give us. And it actually, it quantifies them. It turns it into a dollar amount, right? So that tree that we have out here in this yard, that large tree, saves the homeowner or the business owner or the city, if it's in a park, $279 a year, or gives that homeowner that worth of benefits through stormwater maintenance, by reducing electricity, by improving our air quality, property value, so just the aesthetics and the shade that it provides, and then heating and CO2. So trees really are pretty phenomenal, not just in our enjoyment of them, but in the actual economic benefits that they give us as well. Okay, so we're going to jump over to our other little tree really quickly. So I just went back to calculate a new tree up there on the top. I'm going to switch it. That was a blue spruce. And if you'll notice, it goes spruce comma blue. And that one was 6. And we're going to also say single family residential for that as well. Okay, so this one gives us $40 a year worth of benefits. If we jump over to the CO2, we have about the same number, a little lower than what our other model had shown for how much it sequesters, but quite a bit for how much is avoided. So again, this means the carbon that the tree stores. This means the carbon that it eliminates us from having to produce, from having to give off into the atmosphere by our activities. Okay, so again, that's www.treebenefits.com. And if you have any questions about that, feel free to email me, but I would really encourage you to go to the website and play around with some of the trees in your school grounds or in your yard or in a park at home. I'm going to switch over from sharing my screen and head back to the PowerPoint. So what does this mean when we talk about all these numbers and measuring the tree and figuring out its carbon? What it means is that trees are really important to us. Having healthy, sustainably managed forests all around our state is an important tool in fighting against climate change. Taking care of the trees in our yards and in our parks and in our school grounds helps them become even bigger, which we just saw really increases how much carbon they can store. Planting more trees in our yards and our schools and our cities will help even more. So I'm encouraging you to get involved with your school's environmental or outdoor club or green and healthy school club if they have one. If your school doesn't have one, talk to your favorite teacher and see if you can get one of those clubs started. You can talk to the adults that you live with and try to encourage them to plant some more trees in your yard. Talk to your landlord if you have one. Trees can be purchased for quite inexpensively through the state, and you can ask me for some more information about that. But really, just anything you can do to start to plant more trees and to be a supporter of the forests that we have and sustainable management of the forests that we have in our state. You could even consider writing a letter to your city government to encourage them to plant more trees. So maybe that's a project you want to get your ELA teacher involved with at school. And don't forget to show them the information about how much economic benefits trees can provide. I mentioned in the video that we do have some materials for loan and that is free. If you want to find out more about borrowing those materials to help measure trees, just give me an email, shout me out with an email, and my address is down there, nicole.filizzetti@uwsp.edu. Teachers, if you're watching and you want some copies of the worksheets or information about where the lessons came from, let me know. I'd be happy to talk to you about that. And I'm just going to switch back to video for one last little minute.
Okay, go.
Okay. Thanks again for joining me today. I hope you found our time together to be interesting and informative. Don't forget to email me with any questions or for resources. And have a great afternoon. Thanks and take care.
I hope you're all ready to head outside and measure a tree, whether it's in your yard or at your school or any place nearby where you live, and see the benefits that those trees are producing for us. I also hope you check out all the other videos we have in the Classroom Learning series, which are on our YouTube channel and can also be found on our website. And have a fantastic day. Bye.